Traditionally, in computation and processing data, we would bring the data to the computer. You'd run a program and you'd bring the data into the program. In a big data cluster, what Larry Page and Sergey Brin came up with, this pretty simple, is they took the data and they sliced it into pieces, and they distributed each, and they replicated each piece or triplicated each piece, and they would send it, the pieces of these files, to thousands of computers. First it was hundreds, but then now it's thousands, now it's tens of thousands. And then they would send the same program to all these computers in the cluster. And each computer would run the program on its little piece of the file and send the results back. The results would then be sorted, and those results would then be redistributed back to another process. The first process is called a map or a mapper process, and the second one was called a reduce process. Fairly simple concepts, but it turned out that you could do lots and lots of different kinds of, handle lots and lots of different kinds of problems in very, very, very large data sets. So the one thing that's nice about these big data clusters is they scale linearly. You add twice as many servers and you get twice the performance, and you can handle twice the amount of data. So this just broke a bottleneck for all the major social media companies. Yahoo then got on board. Yahoo hired someone named Doug Cutting, who had been working on a clone or a copy of the Google big data architecture, and that's now called Hadoop. And if you Google Hadoop, you'll see that it's now a very popular term. And there are many, 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 if you look at the big data ecology, there are hundreds, if not thousands, of companies out there that have some kind of footprint in the big data world. Most of the components of data science have been around for many, 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 many decades, but they're all coming together now with some new nuances, I guess. At the bottom of data science, you see probability and statistics. You see algebra, linear algebra. You see programming, and you see databases. They've all been here. But what's happened now is we now have the computational capabilities to apply some new techniques, machine learning, where now we can take really large data sets, and instead of taking a sample and trying to test some hypothesis, we can take really, really large data sets and look for patterns. And so back off one level from hypothesis testing to finding patterns that maybe will generate hypotheses. Now this can bother some very traditional statisticians and gets them really annoyed sometimes that you're supposed to have a hypothesis that is independent of the data, and then you test it. So once some of these machine learning techniques were really the only way you could analyze some of these really large social media data sets. So what we've seen is that the combination of traditional traditional areas, computer science, probability, statistics, mathematics, all coming together in this thing that we call decision sciences. Our department at Stern, I'll give a little plug here, we happen to have been very well situated among business schools because we're one of the few business schools that has a real statistics department with real PhD level statisticians in it. We have an operations management department and an information systems department. So we have a wide range of computer scientists to statisticians to operations researchers. And so we were like perfectly positioned, as a couple of other business schools were, to jump onto this bandwagon and say, okay, this is decision sciences. And Foster Provo, who's in my department, was the first director of the NYU Center for Data Science. 4 years ago, maybe 5 years ago. I mean, this is one of those cases where you can just go to Google and search for data science and see how often it occurred, and you'll see almost nothing and then just a spike. The same thing you would see with big data about 7 or 8 years ago. So data science is a term I hadn't heard of probably 5 years ago. The first question is, what is it? And I think faculty and everybody's still trying to get their hands around exactly what is business analytics and what is data science. We certainly know the components of it, but it's morphing and changing and growing. I mean, in the last 3 years, deep learning has just been added into the mix. Neural networks have been around for 20 or 30 years. 20 years ago, I would teach neural networks in a class, and you really couldn't do very much with them. And now, some researchers have come up with multi-layer neural networks in Toronto, in particular, at the University of Toronto. And that technology is now rapidly expanding. It's being used by Google, by Facebook, by lots of companies.